Welcome in this session. This session, we are going to discuss a problem on how to find limit of a function of two variables, x and y. So the problem evaluate limit. The function is x squared minus y squared over x squared plus y squared, xy approaching 0, 0. Good. So this being the origin, it means that if we carry out step 1 and step 2 and the answers are the same, we'll have to go to step 3, and if they're the same, we'll also go to step 4 before we make a conclusion. So remembering the steps we listed earlier on how to determine limits of a function f of x, y as x and y approaches the origin. So solution, step 1 is to start by replacing x equals to 0, then y equals to 0, i.e. limit. So this can be written as x approaches 0, y approaches 0. So limit as y approaches 0, then you put in brackets limit as x approaches 0 of x squared minus y squared over x squared plus y squared. So this square bracket, we evaluate the limit by simply doing direct substitution. So we'll have limit y approaching 0. Now, whether this x put 0, so it'll be 0 squared minus y squared over 0 squared plus y squared, which is the limit as y approaches 0 of negative y squared over y squared. And this just be the limit as y approaches 0 of negative 1, which is negative 1. Limit of a constant is the same constant. So call this one f1. Now step 2, you put now y equals to 0, then x equals to 0, the reverse of the first step, i.e. we have limit x approaches 0, y approaches 0, x squared minus y squared over x squared plus y squared equals to limit as now x approaches 0, then you start with limit as y approaches 0, x squared minus y squared over x squared plus y squared. And then by direct substitution, you have limit as x approaches 0. So where there's y, you put 0. So you'll have x squared minus 0 squared over x squared plus 0 squared. And this will be limit as x approaches 0 of x squared over x squared, and x squared over x squared is 1, and limit of a constant is always the same constant. So this is our f2. Now, since f1 and f2 are not the same, then it will be enough. It's enough for us to stop and conclude that the limit of this function doesn't exist. So since f1 equals to -1, which is not equals to f2, which is 1, then we conclude that the limit of the function given f of xy does not exist. So the limit of the function given f of xy as x approaches the origin doesn't exist, i.e. we write a limit x squared minus y squared, x squared plus y squared, xy approaching 0, 0 does not exist. So that's enough for us to conclude. Once the value in step 1 is not the same as the value in step 2, so there's no need to continue with other remaining 2 steps. Thank you.